Good morning and welcome to Tech 293 for Thursday, February 4th. The purpose of today's video is to review the material that we've talked about so far in this class in the first maybe 1/3 of the semester, and to give a little preview of the first exam. So we'll talk about the material that's going to be on the exam and the format of the exam. So the first exam, if we look at the schedule, the first exam is going to be on Tuesday, February 9th. And I don't care when you take it on February 9th, so I'm going to set RegiNet to have the exam open at midnight, 12 o'clock a.m. on February 9th. And then you can take the exam anytime on February 9th. It's going to close at 11:55 p.m. on February 9th. I do want you to take it in one sitting, and so there is going to be a time limit. So there's a 3-hour time limit from the time that you start. So pick any 3-hour window inside the day of February 9th and set that time aside to take exam 1. 3 hours is what I normally do for tests and quizzes in all of my classes. I think that should be plenty of time. It's not going to be enough time to go back and watch all the videos, of course, nor will it be enough time to read all the material in the lab manual. So, it's gonna help you out a lot if you've watched all the videos and done all the reading assignments, because then you'll kind of know where to refer to. If you remember reading something or hearing something and you need to refresh your memory, you could go back and take a look at that material again. So it's definitely worth your time to watch all the videos ahead of time and to read all of the material in the lab manual ahead of time. All right, so that is exam 1. If we look at the schedule, we also have lab 3 due coming up. That's hardness testing that we did last time. And normally I make the lab reports due 1 week after we do them in the lab, but I don't want to have the lab report due on the same day as an exam. So I'm actually going to push lab 3 back just a little bit. And it's correct in the schedule. It says lab 3 is due on February 11th, and that is the day, the class session after exam 1. So lab 3 will be due on February 11th, as it says in the schedule. And that is a little bit more than 1 week after we did lab 3 in the class. All right, so exam 1 on February 9th by 11:55 p.m. and lab 3 due on February 11th, also by 11:55 p.m. All right, so that's about it for the schedule. Now let's go ahead and take a look at the material for the exam. And I'm going to share my screen because I have some slides on this. All right, exam 1 preview. All right, so it's going to be basically all multiple choice, with a number of different answers that you can choose from. Some of those might be structured in a true-false format where a statement's either true or false. And there will almost certainly be some calculation problems. Probably not as many calculation problems on exam 1 as there will be in exam 2 and 3, but we've still done some calculations in the first third of the semester. So you can definitely expect some calculations, but they will still be structured as multiple choice questions. So I'll just give you a bunch of possible answers and you will select the correct answer after doing the calculation. What you should have with you when you sit down to take this exam, you should definitely have something to write with and a piece of scratch paper, because there are going to be some calculations. And you should also have a calculator for the same reason. And I'd recommend having your lab manual as a reference right there with you, and the labs that you have done right there with you as well as a reference. This exam is obviously going to be all online, and so therefore I know that I can't really restrict what materials you use, but I don't think that's that big of a change from previous semesters. So it's not that big of a difference, because in previous semesters, in all of my classes, I always let students make and bring a notes page, one standard sized page, front and back, handwritten, are my standard guidelines for a notes page. And I think that is completely reasonable. And so this goes this semester a little bit beyond that, because I realistically can't prevent you from using your lab manual and your notes and things like that. As I mentioned earlier in the semester, the one thing I don't want you to do is be communicating with other students during or immediately after the exam. Students often assume that it's difficult to catch academic dishonesty on online exams, but it's not really that difficult. RegNet gives a lot of information, and so I can see obviously what answers you select, and I can see what time you select them, and so there's a lot of data. So let's not go there, and let's not test this. It seems like every semester I do end up dealing with something like this, and I do not enjoy it at all. So just don't collaborate with anybody on the exam, and we won't have to go down that road. I will say, because I have dealt with this kind of thing almost every semester, that unfortunately influences the way I structure the exams. And that is why I make RegNet randomly order the questions, so it mixes up all the questions. And that's also why I make it so that there's a next button, but not a previous button in RegNet. I think that's kind of unfortunate, but you know, I've had too many experiences with dealing with this kind of thing, so that's just the way I do it from now on. So that's the way it is. All right, but you can use all these resources down here, and I'd encourage you to do so on the first exam. So a quick review of what we've talked about in the first third of the semester. We've talked about materials testing and who would do it, what they would test, when they would test it, where and why they would do this testing. We've talked about various different material properties that we can test. And we've talked about the difference between intrinsic properties and extrinsic properties. And if you recall, we're normally much more interested in intrinsic properties for materials testing. Not to say that extrinsic properties aren't important. You know, if you're making a car, it's important that the crankshaft of the car is a certain length and a certain diameter, you know, which are extrinsic properties. But if we're doing materials testing, you know, that's more like finding the flexural modulus of the crankshaft. And that would be an intrinsic property because it doesn't matter how much of the stuff you have or how long it is or the width or anything like that. We talked about these different terms and defined them, and I would expect you to know what they are. We haven't used these extensively in applications or lab problems yet, but I want you to know what is strength and what is stiffness or rigidity. Those two are synonymous. Stiffness and rigidity are synonymous, but these two are not synonymous with strength, and these are not synonymous with hardness either. These are different concepts here. And we've talked about different kinds of deformation, causing something to change shape. We've talked about elastic deformation, which is temporary, and we've talked about plastic deformation, which is permanent deformation. Then when we got into discussing how we test materials, we talked about how we do tensile testing, and we'll talk more about this in the next section of class. But we talked about which is the independent variable and which is the dependent variable for tensile testing. And that's a little bit counterintuitive. It might not be what you expect. Then we gave a definition and talked a little bit about stress, and we gave an equation. So I would expect you to be able to do simple calculations for stress. We'll do more in the subsequent sections of the class. Same thing for strain. You should be able to do a simple calculation to calculate the strain of a material specimen. I expect you to know what necking is. We talked about it a little bit, and I showed a couple of pictures about what necking looks like. And on a pretty basic level, we talked about what is impact testing, and one type of impact testing that we'll talk a lot more about later on is called Sharpie V-notch testing. That's actually what we're going to do for the second part of Lab 7 later on. And we talked about a couple of short-term tests versus long-term tests. And I said that we don't really have time to do long-term tests in TEC 293, but we can at least talk about a couple of them briefly. And one of them was fatigue. So we talked about fatigue for just a couple of minutes, but I want you to know what fatigue is. And the other one that we talked about was creep. So again, we don't really have time to do creep testing in class, but I want you to know what it is. Then we started talking about materials science, and we divided this into three parts, three different days that we talked about materials science. First, we talked about the 4 different types of bonding. 3 of those are atomic level bonding, and one of them was molecular level bonding. And we talked about these 5 different groups of engineering materials and what characteristics those 5 groups have. And we talked about the phases of matter, solid, liquid, and gas, and what factors determine whether a given material is going to be a solid, liquid, or a gas at a given temperature and pressure. So among the atomic level bonds, we talked about the properties of ionic bonds and some of the characteristics of materials that are made of or held together with ionic bonds. Same thing for covalent bonds. We talked about what they are and the properties of materials that are held together with them. And same thing for metallic bonds. And then the 4th general type of bonding that we talked about was intermolecular bonds, aka van der Waals forces. And a particularly strong type of van der Waals forces is a hydrogen bond. So you should know what a hydrogen bond is and what are the atoms that are prone to engage in hydrogen bonding and how does it work. And we also talked about lattice structures, otherwise known as Bravais lattices. You should know how many different types of them there are. And then you should know some more details about the 4 types of lattices that we talked about in slightly more depth. Simple cubic, body-centered cubic, face-centered cubic, and hexagonal close-packed. You should know some details about each one of those, the mechanical properties that they impart to their materials that are made with these different lattice structures. And you should know the packing factor, the quantitative value of the packing factor for each of these 4 different types of lattice structures. In that same session, we talked about different kinds of alloys and what an interstitial alloy is and what a substitutional alloy is. Or we can have both. We can have alloys that are both interstitial and substitutional at the same time. We also talked about grains, and we talked about the process, and I showed a video about how grains form during the solidification or freezing process from a liquid material to a solid material. And we talked about the influence that grain size has on the mechanical properties of the material. In other words, let's say you have the same type of material, 1040 steel, something like that. How would the mechanical properties differ between 2 different specimens of 1040 steel, one of which has very, very small grains and the other which has much larger grains? How would those mechanical properties differ? Later on in the class, we'll talk about how you can do that, how you can get larger grains or how you can get smaller grains, and what benefits that might have. But for now, I just want you to know the impact on the mechanical properties. We talked in general terms about metals. That's one of the 5 groups of engineering materials. We'll talk a lot more about it in the 2nd and 3rd thirds of this class, but we talked in a little bit of detail about ferrous metals versus non-ferrous metals, what defines that distinction, and some characteristics of each, and some general properties of metals, like how hard they are, how strong they are, how conductive they are, things like that. Then we talked about kind of the same thing for ceramics. We talked about what they are, what they're made up of, how they're defined, and some mechanical properties of ceramic materials. Then we did the same thing for the other three of the engineering materials, for polymers and for wood and composites. We talked about how those things are made up, what are their constituent materials, how are they made, and we talked about properties of each of them. And we kind of did a little bit of a comparison with regards to strength and ductility and hardness and conductivity. And the last thing that we talked about in this first third of the semester is hardness and hardness testing. So we talked about what is it, what is hardness, and why might we care about hardness. And then we talked about how to determine the hardness of a material. And to do that, we had to talk about different scales because remember, it's test method dependent. I can't just give you some parameters of a particular material and tell you to calculate the hardness. It doesn't work like that. It's all experimental, and it's experimental based on the different scales and test methods that we use to test for hardness. So you should know something about each of the three basic methods that are most common to test for the hardness of a material. The first of those three was called the Brinell hardness testing procedure. You should know the general procedure, pretty straightforward, and some of the pros and cons of Brinell hardness testing. And then we talked about Rockwell hardness testing, which is a lot more common than Brinell hardness testing. You should know about the different scales, most commonly the Rockwell B and the Rockwell C scales, what kind of indenter they have, and when you might use each one for what kinds of materials. You should know that procedure. There was like a 5-step procedure with some dwells in between. You should know that procedure and why we do each step in that procedure. There's a very good reason for each one of those steps in that procedure. So you should be able to describe the Rockwell hardness testing procedure. There were also some precautions that were important to note when you're doing this testing, and some pros and cons to Rockwell hardness testing. Same kind of thing with Shore hardness testing, which remember, Shore is the scale, the durometer is the piece of equipment that you use. I see people confusing those things all the time. So you should be able to tell me what type of material we do Shore testing for, the procedure. There isn't much of a procedure, but describe it, and some precautions and the pros and cons of Shore hardness testing. For the labs, we've done 3 of them in this section. The first lab involved calculating density and correlating density to ultimate tensile strength. What you probably saw in lab 1, and what I would probably say, is that there's a loose correlation. It's certainly not a perfect correlation. It's not like all your data points were on a straight line. I'm certain of that. But there's a general loose correlation, if nothing else, than say above for metals themselves. Among metals, generally speaking, there's a loose correlation between density and ultimate tensile strength. There are exceptions. Like copper is very dense, but not super strong. Lead's another one like that. Lead is very dense, but not really that strong. So there are exceptions to that. But as a general trend, it's fair to say that higher density correlates with higher ultimate tensile strength. And you'd say the same thing and see the same thing among woods and among plastics also. In lab 2, we calculated the spring constant, K, and we did some calculations like calculating the load for a given deformation, like a given stretch in the material, or vice versa, calculating the amount of stretch necessary for a given load or force. All right, so either one of those, there's a relationship between those two, and you should be able to use the spring equation or the best fit trend line that I give you, just like you did in Lab 2, to calculate either one of those. So you should be able to manipulate that information to calculate either the load or the deflection, whichever one is not given. In Lab 3, we did hardness testing, and you should be able to describe the procedure that we use for hardness testing using the scales that we did in Lab 3. And you should also know something about when you would use each scale. So if I gave you a piece of rubber, would you use Rockwell C testing for a piece of rubber? Probably not. That would not be very appropriate. So you should know, generally speaking, when to use each of the hardness scales. All right, that about wraps it up for the first third of the semester. So don't forget to take the exam on Tuesday, February 9th. Put a reminder in your phone or write it on your calendar or something that reminds you to take it on February 9th. Also, make sure you give yourself the full 3 hours. There's no reason to cut yourself short. So don't start the exam at 11 p.m. That would be pretty silly. Start it by 9 p.m. at the very latest so that you have the full 3 hours to complete the exam. All right, if you have any questions in the meantime, before the day of the exam, then by all means, please let me know. I'm always happy to help. So otherwise, good luck on the exam, and I'll see you next time.